A data scientist once built a model that predicted disease with over 95% accuracy. It looked perfect until they deployed it. Suddenly, it stopped working. Not a small drop. It completely failed. The problem? Not the model, not the code. It was something much simpler and way more dangerous. They didn't understand their own data. I'm Yukari Esther, and this is NeuroBloom, where we make complex technology actually understandable. So, that sounds interesting to you? Consider subscribing and leaving a like. It really helps the channel grow. And if you'd like to directly support future videos, you can also support me on Buy Me a Coffee. So, with that said, let's dive into it. This happens more often than people admit. There's this hidden phase in data science that doesn't look impressive. No fancy AI, no complex math, just looking at the data. It's called EDA, Exploratory Data Analysis. And ironically, it's the step that separates the beginners from professionals. EDA is the process of investigating your dataset before doing anything serious with it. You're not trying to build, you're trying to understand. Think of it like asking your data questions. Who are you? What do you contain? Can I trust you? Because data, by default, is messy, incomplete, and sometimes straight up misleading. Let's upgrade the cooking analogy. Imagine you are in a professional kitchen. You receive a box of ingredients labeled premium quality. Sounds great. But then you open it. Some vegetables are rotten. Some labels are wrong. Some ingredients are missing. And something inside you can even identify. Now, here's the question. Do you start cooking immediately? Or do you inspect everything first? That inspection is EDA. Here's the uncomfortable truth. Most datasets in the real world are like that messy box. They're not clean. They're not organized. They are chaotic. When you perform EDA, you're basically running an investigation. When data scientists do EDA, they usually start by asking a few basic questions. First, they look at the structure of the data. How big is this dataset actually? How many rows are there? How many columns? And what kind of information are we dealing with here? Are these numbers, categories, dates, text? Then comes the quality check. Are there missing values hiding somewhere? Did some rows get duplicated by accident? Is part of data corrupted? After that, they look at distribution. Are the values spread naturally? Or is something weird going on? Maybe most numbers are small, but a few are insanely large. Those are called outliers, and they can completely distort your analysis. And finally, relationships. Do some variables move together? Does one feature affect another? Are there hidden patterns inside the data? At this stage, you're not trying to solve the problem yet. You're learning the terrain, understanding the battlefield before making any decisions. This is where visualization becomes powerful. Instead of starting at numbers, you start seeing patterns. A histogram reveals if data is skewed. Skewed? I guess it's skewed. A scatter plot shows relationships. A box plot exposes outliers. Suddenly, the dataset stops being a spreadsheet and starts telling a story. Let's say you're analyzing customer data for a company. Everything looks normal until you plot age distribution and you notice something strange. There are customers aged 200 years old now. Unless your business is vampires, something's wrong. That's EDA saving you from disaster. Sometimes the issues are more subtle. A column might look fine, but actually contains hidden bias. For example, a model predicting job success might accidentally rely on a feature that indirectly encodes gender or location. If you don't catch that during EDA, your model becomes not just wrong, but unfair. Fun fact, the reason EDA became popular is largely because of statistician John Tukey. I don't know. He basically said, before jumping into complex models, just looked at the data. Simple idea, massive impact. Here's what beginners usually do. Load the dataset, train model, celebrate accuracy. No question asked. That's like taking a mystery box, throwing everything into a blender and hoping it tastes good. Sounds like me cooking. Professionals don't do that. They slow down first so they can go faster later. EDA directly influences your next steps. You discover missing values. You handle them properly. You find squid data. You transform it. You detect irrelevant features. You remove them. Even model choice depends on EDA. Linear model, tree-based, neural network, data tells you. Let's get slightly technical, but keep it simple. Some of the most useful tools in EDA are surprisingly simple. For example, there's a command called describe, and all it really does is give you a quickly summary of your data. Things like the average, the minimum, the maximum, and how spread out the values are. It's basically your dataset introducing itself. Then there's info. This one helps you understand the structure of the data. What type is each column? How many values are missing? Is this numbers stored as text for some reason? And trust me, that happens more than it should. You also have something called correlation matrices. That's just a fancy way of checking where variables are related to each other. Like when one values go up, this another values usually go up too. And then come the visual tools, histograms, heat maps, scatter plots. Because sometimes your brain understands patterns faster through pictures than through raw numbers. None of these tools are flashy, no futuristic AI, no magical algorithms, but they are incredibly powerful because they help you stop guessing and start understanding. Here's something most people don't realize. EDA is not just about detecting problems, it's also about finding opportunities. Maybe a hidden pattern gives you a new feature, a trend reveals a business insight, a relationship suggests a new hypothesis. EDA doesn't just fix data, it creates ideas. Sometimes EDA leads to a hard conclusion. This data is not usable. And that's actually a success because discovering bad data early is way cheaper than building a broken system. So let's wrap this up. EDA is the process of exploring and understanding your data. It helps you to detect error, uncover patterns, and guide decisions. It helps you to detect errors, uncover patterns, and guide decisions. It's not optional, it's foundational. Skip it, and everything you build becomes fragile. Now, I want to hear from you. What's the weirdest thing you've ever seen in a dataset? Drop it in the comments. Seriously, I love these stories. And honestly, this is only one small part of what happens before a machine learning model is ever built. There's an entire world behind the scenes of data science that most people never get to see. So if you enjoyed this video, hit the like button, subscribe, and stick around for more. See you in the next one. Bye!